right, class, here are the solutions to worksheet 3.6. I'm going to go over every problem. Believe it or not, these problems are about half as complicated as the ones I did in class. So a rectangular sign is being designed so that the length of its base, we'll call that L, in feet is 10 feet less than 4 times the height. So the area of this rectangle is going to be its length times its height. And they tell me something about the length. They tell me that the length is 10 feet less than 4 times the height. So I can write length in terms of height. So it's 4 times the height minus 10 feet. Now I can define the area of the sign as a function of h if I take a of h, so that just tells me it's a function for area defined in h, would be h, my height, times my length, which is 4h minus 10. I'm then going to go ahead and distribute, so I have a of h equals 4h squared minus 10h, which would give us b as our answer. For problem 2, I'm given a length of wire that is 9x long. I don't know what x is. And what I'm going to do is I'm going to bend this into the shape of a square. So that means each of the sides is going to be 9x divided by 4 long, right? If I took this wire and I broke it up into fourths so that I could bend it into a beautiful square, each of the side lengths would be 9x over 4. Well, the area of a square is the length of its sides squared. So if I want a function in x for the length of this square, I'm going to have to take the length of one of its sides, which are all equivalent, squared. So the area of x equals 9 squared, which is 81, x squared over 4 squared, which is 16. So my answer for this equation is A. Next, problem 3. This is the one where I got kind of stumped in class in the last few minutes, and it's because I forgot something about isosceles triangles. So isosceles triangles, both sides are the same, right? And if I inscribe a box in there, right, this length is going to be the same as this length, and this will still be an isosceles triangle. That's one of our rules about isosceles triangles. So I want to take the area of a rectangle, which is going to be its length times its height. Well, I know my length, right? It's a perfect rectangle. It's centered at 0. This is negative x. So the length is going to be 2x. It's my height that I'm not sure of. I need to figure out what this is. Well, this is 3 minus x. If I have this whole length, it's 3. This little bit here in orange would be 3 minus x. Now, because this is an isosceles triangle, both of these sides are the same, so my height is also 3 minus x. So to find the area of my triangle in terms of x, I'm going to take the length times the height. Because we're finding the height for the rectangle. So that's what I meant. We're finding the height of the rectangle, not the triangle. This is a rectangle. For problem 4, I have a box with an open top that's going to be constructed from a rectangular piece of cardboard that measures 12 inches by 23 inches. Okay? I'm going to cut squares out of each corner of length x and then fold the sides in like this figure. So I cut out x, and then this is x, and this is right here, and this is right here. Okay? So I know my height is x. What's my orange length right here? Well, I had 23 inches, but I took away 2x, so this becomes 23 minus 2x. In green, this length over here would be 12 minus 2x, because I took away 2 x's. And the volume of a box is length times width times height. So my volume expressed in terms of x, so my volume as a function of x is going to be x times 23 minus 2x times 12 minus x. So our answer is going to be not C, not B. This is going to be A. I just had them written backwards. Last but not least is a distance problem. So if I have the distance between any 2 points, that's going to be x squared minus x1 squared plus y squared, y sub 2 minus y sub 1 squared. Well, I have 2 points. I have the point xy and the point 0, 1. So my distance is the square root of x minus 1, I'm substituting in my 2 points, plus y minus 0 squared. So my distance is the square root of x minus 1 squared plus y squared. And I want to have this function be in terms of x. So I'm going to have to substitute in for y, and I know y equals the square root of x. So I have distance as a function of x, which is x minus 1 squared plus the square root of x squared. So I need to go ahead and FOIL this out. So that's going to give me the square root of x squared minus x plus 1, and then the square root of x squared just gives me an x. So I'm left with the distance as a function of x is defined by the square root of x squared minus x plus 1. So my answer would be C. Therein, I have covered worksheet 3.6. If you guys have any questions from the homework or from the text, feel free to shoot me an email.